Most of the AI we use every day lives behind a screen, right? It's in our search engines, our translation apps, our recommendation feeds. But what happens when that intelligence gets a body? When it steps out from behind the glass and into our world? Well, let's dive into that transformation. The incredible journey of robotics from being just a tool to becoming a true teammate.
So right off the bat, we've got to draw a clear line. A typical AI, the kind we're used to, is pretty passive in the real world. It waits for you to type a search query. It waits for your click. You're the one who's active. A robotic system, though, it's the complete opposite. It is an active agent. It has sensors, it has motors, and it's interacting directly with its environment. And hey, that environment includes us.
So what's the big deal? What really makes putting an AI in a physical body so radically different?
Well, it's all about one thing, the challenge of the real world. A robot isn't just a smart machine, it's a smart machine that has to deal with reality in all its messy, chaotic, and unpredictable glory.
Okay, so here's the basic definition we're working with. A robot is a physical agent. It's connected to the world through its sensors, things like cameras or touch sensors. It uses those to perceive what's around it. And then it uses what we call effectors, arms, wheels, grippers, to actually act on the world. It's a constant cycle: perceive, decide, and act, all on its own.
And this is where the AI hurdles get really, really interesting. A robot is in what's called a closed loop with the world. That means one tiny mistake can get amplified and snowball into a huge problem. It has to make decisions with only partial information from its own, often noisy sensors. And maybe most important of all, its actions have real physical consequences. There's no undo button.
So with all these massive challenges, how do we even begin to build robots that can actually work alongside us? The answer is a guiding principle called the human-centered approach. This is all about designing a true partner, not just a simple replacement.
And this quote just nails it. The whole point is to collaborate and empower. A robot that's actually helpful shouldn't be a burden. It shouldn't be something we have to constantly babysit or figure out how to work around.
This right here is the core philosophy. Think about your robot vacuum. If it gets stuck under the couch, who has to adapt? You do. You have to move the furniture or set up a little barrier. Human-centered robotics wants to flip that script entirely. The goal is to build a robot that can adapt to us and our messy, unpredictable homes and workplaces, not the other way around. Now, to make that shift happen, a robot needs these 4 core abilities. It needs autonomy to function without constant handholding. It needs to be robust to handle surprises. It needs to learn from its experience to get better. But that last one, open-ended learning, that is the holy grail. It means the robot can build its own understanding of the world as it goes, instead of just following a pre-written program.
Okay, so if a robot has these abilities, how does it actually connect with us?
If we're talking about a true partnership, communication is everything, right? It turns out it all boils down to 3 fundamental channels of interaction.
We can connect with robots in 3 main ways: through direct physical touch, through spoken language, talking, and through all the nonverbal stuff, like gestures and body language. Let's break each one down.
First up, physical interaction. This is when a robot makes direct contact with a person, like an exoskeleton helping someone with physical therapy. In these cases, one thing matters above everything else: safety. It is absolutely paramount. The system has to be designed from the ground up to be physically safe for its human partner. No exceptions.
All right, second, we have verbal interaction, just talking to the robot. But the real challenge here is so much deeper than just recognizing words. If you tell a robot to go through the door, it doesn't just need a dictionary definition of door. It needs to know what that specific door over there is in its own environment.
And this gets at a classic, massive problem in AI called symbol grounding. It's all about how you connect an abstract symbol, like the word chair, to the robot's actual physical experience. What its camera sees, what its gripper feels, and the understanding that a chair is a thing you can sit on. It's a huge deal.
And finally, we have nonverbal interaction. Because a robot has a body, it can communicate a ton without ever saying a word. It can use gestures, its posture, where it's looking, and even just its physical appearance sends a strong message.
And appearance is incredibly tricky. This brings us to the famous uncanny valley theory. The idea is that as a robot looks more human, we tend to like it more, but only up to a certain point. When it gets almost human but not quite perfect, it just feels eerie and unsettling. It's a perfect example of how sensitive we humans are to all these nonverbal cues. So let's just pause for a second. Let's say we do it. We build a robot that understands our touch, our words, and our gestures. Is that it? Is that enough for a real partnership?
Not even close. Because collaboration is a two-way street. It's not just about the robot understanding us, we have to be able to understand the robot, too.
And that is a huge challenge. I mean, think about it. We can't really imagine what it's like to see the world through a laser scanner. A robot's decisions are based on complex algorithms that are fundamentally alien to our own intuition. We just don't have that shared experience, those shared instincts to fall back on.
So the solution is to design robots that can translate their weird internal state into a language that we can actually understand. Sure, this could mean explicit explanations, but it's often more subtle stuff, using gestures, changing the direction of its gaze, or even a simple touch that communicates, "Hey, I've got this. You can let go now."
And all of this brings us to our final section. Because when you move beyond the technical hurdles, you realize that building these robotic partners forces us to face some of the biggest social and ethical questions of our time.
To guide us, people have proposed frameworks for trustworthy AI, which are built on key principles like these 7. It's about ensuring humans always have oversight and ultimate control. It means making sure the systems are robust and safe, and that our privacy is protected. It also means building in transparency so we can understand their decisions, ensuring fairness, and having clear accountability when things go wrong. These aren't just nice-to-haves. They are the absolute bedrock for building AI that truly serves humanity.
And that leads to a final, really profound point. This quote highlights a fundamental truth. We may be the ones designing the technology, but that technology inevitably turns around and shapes us, how we work, how we interact, and maybe even how we see ourselves.
And that leaves us with a critical question to think about. As we build these increasingly sophisticated robotic partners, as we move them from being simple tools to true teammates, are we really prepared for how they, in turn, are going to reshape us?